Zombie Apocalypse.
Okay, today's discussion is to check isa sa mga serviceability condition ng isang precise concrete beam, which is deflection, in the form of camber. So we will try to discuss right now yung mga camber formula derivation na dependent dun sa types of tendon profiling na i-apply. So let's get ready to be neurorized. Okay, so topic for today is tendon profile in form of a rectangle, no? So before we proceed to that, meron tayong isang generic equation na dapat sundin. In this equation, that delta t, as shown here, delta t equals delta sub L plus delta sub C. Si delta sub t, siya yung total deflection, siya yung i-check natin na merong quantification sa code, na limiting value para masabi safe or unsafe. And most likely, we will expect total deflection that should go up kasi our main objective of the beam is to camber, or to deflect upward. If you recall, in our past discussion, our main objective is to produce an upward deflection as a total. Yun yung sinasabi natin total deflection. Si delta sub L is the deflection due to load. So, most likely, that is taken from the loads, usually gravity pulled. So, syempre, kung may load kang pababa, okay, like concentrated o kaya uniformly distributed, okay? So, that will be a reference to theory of structures. Ngayon, if you forgot yung sa topic of calculation of that, you can refer to my theory of structures playlist and then try to check out kung ano yung mga methods sa pwede mong i-adapt for you to find out ano yung maximum deflection dun sa particular beam in question. So, may I refer you to my playlist and to those specific topics na found on my playlist, okay, in this same channel. Now, also, delta C is a deflection due to pre-stressing force. Ito yung pinaka-main interest natin today that we are going to discuss, okay? So, we will try to adapt some methodologies for us to find ano yung methodology na ginagawa to compute for delta for deflection due to pre-stressing force or delta C. C refers to camber. Most likely, it will go up. So yun nga lang, we don't know the effect of the total deflection na in function to the due to load. So maaaring tumaas o bumaba. Kaya i-investigahan natin as we progress in one of my video lectures. And don't forget that the sign convention for deflection, basta for the meantime, pag umakyat, pataas, kapag bumaba, negative. Okay? Okay. So, most likely, ang pinaka-fundamental type of tendon profiling is a rectangular. So, sa rectangular loading kasi, sa rectangular tendon profiling, hindi kasi dominante yung mga types of load na pwede natin i-consider. I'll try to mark the area blue. Yan. Yan yung pinaka-concrete area na makaka-capture, for that particular reason, yung sa due to pre-stressing, which is we are aware already that the pre-stressing force, okay, is being applied to both sides and then with a angle theta which is very small, okay. Ngayon, tingnan natin paano ba nag-originate ito. Okay, so most likely ito yung pinaka-fundamental, so we will try to understand na kapag nag-drawing ka ng ganitong setup, with E, so therefore don't forget that E is always measured from the lowest point or any point in the system. In this system, nagkataon na consistent rectangular kasi yung kanyang form, kaya tinawag na rectangular tendon profiling kasi makikita nyo, ayan, that is shape of a rectangle, yung shaded region. At E describes the eccentricity. The same eccentricity as discussed in my past video lectures. Okay? So, I always measure from the tendon profile up to the neutral axis. Ito neutral axis, depende na kung ano yung cross-sectional area na in question. Okay? So, let us try to understand. Now, take a look on this, Meron kang portion na makikita dito in between the tendon, okay, and the neutral axis. Yan. So, ulitin lang natin, ito yung tendon, yung nasa ilalim na to, okay? This is a tendon, and nasa taas yung neutral axis. So, when a force is applied below the neutral axis as compression, I already discussed this, na ito ay magproduce ng compression sa ilalim at tension sa taas. Kaya ang deflection nito tataas. Okay? So, ngayon, if you will try to take a look, na andito yung ating tendon, tapos ito yung region ng effective for concrete. Yan yung sinidan ko na violet, yan yung mag-act as a fictitious load. Okay? Siya yung magpapaangat dun sa ating concrete beam. So, fictitious load kasi di naman siya totoong load, pero yan yung naging product of interaction between, there is an interaction of eccentricity E at saka yung force compression P. Yung dalawang yan. So, it turns out to be a moment. Tandaan nyo, pag may bending, may flexion, may moment na kinecreate. Which is under this, we understand that moment equals P times E. No, yung region shaded by that violet portion. Ayan. Okay? Ngayon, in theory of structures or elastic theory, there is a good topic that considers fictitious load and what it is. That's what we call the conjugate beam method. Now, if you recall this conjugate beam method, it converts the actual load into a fictitious load. Okay? Yan yung konsepto nito from theory of structures. Okay? Conjugate beam method ang tawag natin dyan. Okay? So, therefore, we will try to use this topic for us to solve for the deflection that goes up, yung camber, yung delta C. Now, if you miss this topic, I may refer you to my channel, no, yung playlist na theory of structures, and then kindly check na lang sa link above ng video lecture na ito kung ano yung konsepto ng conjugate beam method and try to review it first before you proceed to the discussion. Ngayon, kung napanood mo na at aware ka na kung paano gamitin conjugate beam method, then we may proceed. No? So, therefore, if aware ka na, then let's continue sa discussion ng conjugate beam method. So, again, let's take a closer look dun sa ating calculation. Okay? So, dito, makikita natin na pataas yung load natin, no, fictitious, kasi yan yung effect nito, no, kasi i-compress na yan. Okay, mark in violet. Ayan, tanggalin natin yung kulay para makita malalo. So, ang pressure nito pataas kasi itutulak niya pataas yan. Okay? So, isa yung para maging fictitious load natin. Kaya fictitious load, in terms of if you recall conjugate, kukuha ka ng parang moment, which is P times E lang yan. Kaya this why, over EI. Tandaan niyo ang conjugate beam method, palatandaan niya, dinidivide sa flexural rigidity EI. Ngayon, magkakaroon ng fictitious reaction sa A' at saka sa B'. Again, it is just simply supported fictitious reaction. And then, as if you're solving a concrete beam, no, simply supported, then reaction can be computed as half of the area of the load, which is area of the load, PE over EI, no, times 1/2 of course, times L Kasi you have to multiply this area and divide it by 2. Parang sa statics. So, now provide your concept now on statics for you to get this reaction na PEL over 2EI. However, these are all taken as fictitious reaction. Diba, ang fictitious reaction is equivalent to the slope, no? Say at A and slope at B. Okay? Yan yung topic ng conjugate beam method sa inaral na sa theory of structures. Ngayon, dito tayo magpo-focus. We need to identify anong deflection kaya ang mapoproduce sa gitna. Usually kasi may symmetry portion ang pre-stressed concrete beam na sinasadya sa centerline position ng deflection maximum. Kaya mapapansin mo, ang mga loadings ito ay laging symmetrical. Okay? So, sa gitna ang paghahanap. Kaya may C' ka nag-exist. Okay? New letter yan to introduce. So, therefore, your main objective is to get the moment, no, na makukuha sa C'. So, if you recall that the moment C' or moment fictitious na pag may lagay ng prime, equal lang yan sa actual deflection. So, fictitious and this is the actual. Sa concept yan ni conjugate beam method. Ngayon, as we proceed, I want to take the sigma moment on the left side. Ito yung kukonsider ko. Pwede namang right side. However, pag left side, aware tayo na ang clockwise is positive, counterclockwise is negative. So, let's take advantage on that. Okay lang naman kahit yung kanang side Ito, kukunin ko yung left. If you want to take the right side, okay lang. But don't forget, but if you take the moment on C' taken on the right cut, so dapat malaman natin, ang kinocompute natin is yung counter na yung positive at yung clockwise na yung negative. Explained by this diagram na kapag may bending kang positive, di ba, may cut ka dito, L and R. So, sa positive bending sa left, ito yung positive. Sa right naman cut, ito yung positive. So, that explains the idea. So, therefore, you have to take this equation. So, therefore, you have to take the reaction, fictitious, going to that point. Kaya ito yung nakuha nating equation. Okay? Followed by this load as napataas, iikot ng clockwise, kaya naging positive. Okay? So, then followed by the centroid. So, 1 half of L over 2. So, that's why as you simplify, you will get delta C of negative PEL squared over ATI. Tandaan natin, negative, ibig sabihin yan, it is negative bending. At sa negative bending, aware tayo na pag ganito yan. Tama? So, therefore, deflection is going up. So, that's why we can now conclude that the delta C is equal to PEL squared over ATI, tanggalin ko yung negative sign at tumaas yung deflection niya. So, ito yung formula kapag rectangular yung profile ng tendon. Okay? Pag nasa baba ng neutral axis. Most likely, kapag yan nasa taas naman, so let's say ito yung neutral axis, at nasa taas yung tendon profiling, which is I don't know if mag-exist yan sa pre-stress kasi hindi eh. What will happen is, ang mangyari dyan, de-deflect lang lalo pababa. So, you're not solving the problem as per Camber. So, dinadagdagan mo yung burden ng concrete to deflect. So, the main objective of pre-stress is to produce a camber or deflection that goes up. So, therefore, I think this scenario will not be appreciable for pre-stress concrete design. Okay, so therefore, you have to use delta C equals PEL squared over ATI that goes up for this equation. And this may exist kapag gumagamit lang tayo ng tinatawag na superposition that we will try to understand. Okay, wrong spelling. It should be superposition. Okay. So, parang Varigdon's concept niyan. As we progress, so, magko-compute tayo ng mga, yung nasa dulo ay may value ng mga kanya-kanyang eccentricity. Okay, so thanks for viewing. I hope you learned something new today. And as our tradition goes, you have been neurorized and see you in our next video lecture.